good day, dear participants. We're pleased to welcome you at our event on green chemistry, the innovative approaches in the design for the new products. Our event is held as a part of the out of the Ecology and Green Chemistry conference that is dedicated to 125th anniversary of the Kyiv Polytechnic Institute, named after Igor Sikorsky. And our today's event has been organized by the Center for the Resource Efficient and Cleaner Production, and this together with the Center for Green Chemistry and Green Engineering of the Yale University, and the help of the UNIDO program from the GreenChem Programme that is being financed by the Global Environmental Fund. The green chemistry is one of the most important and progressive directions for the developments of the chemical industry in the recent times, and it has been acknowledged by all over the world. It is present in all of the sectors of businesses and is definitely the main component and principle in the development of the cycle economy. And of course, in order to provide the introduction of the green chemistry approaches in the different industries, we need to show the examples of green chemistry in the educational materials and the educational establishment that is going to impact our future generations of scientists, and hope that they will give them the opportunity to achieve more. So that is why we're about to present the global program of innovation and network program in green chemistry. We will know more about the green chemistry principles being used to improve the ecological safety of production. We're going to talk about the chemistry leasing as an innovative business approach, and we're going to be talking about implementing the green chemistry course into our training programs. We'll have the opportunity to get from the theory to practice. My name is Katerina Romanova. I am the expert on communication and promoting for the Resource Efficient and Clean Production Center in Ukraine, and it is a pleasure for me to be the host of today's event. So let me start with opening of our today's session, and I would like to invite Tetiana Dontsova first. She is the head of Department of Inorganic Substances Technology, Water Treatment and General Chemical Technology from the National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute. So please, Tetiana, the floor is yours. Thank you. Good afternoon, dear participants. It's a pleasure for me to open this event, the event that is titled The Green Chemistry Innovative Approaches for the Design of the New Product, that is being held in the framework of the International Conference on Chemistry, Chemical Technologies and Ecology that is dedicated to 125 years of Igor Sikorsky Kyiv Polytechnic Institute. It is a pleasure for us that this event is being held in the framework of our conference as well, because a lot of our scientists, researchers and students are currently interested in those issues, the issues of green chemistry, creating the new safe technologies and improving the environmental situation in Ukraine overall. So that is why having this kind of event is definitely relevant, it's timely, and it is dedicated to very interesting questions. The one thing that has really made me interested, and if you don't mind, I'm going to take a look at the agenda. I am really looking forward to those really relevant issues, for example, as chemical leasing is. So basically, that will give us the opportunity to use less chemical components and materials in order to create more environmental friendly and resource resilient technologies. So that is why I am really happy to see all of you. I am really happy and honored to start to launch our conference, our event in the framework of our conference. Thank you very much, Tetiana. Thank you very much for outlining this important and timeliness of our today's event. And we would like to pass the floor for the introductory speeches. I would like to invite Lars Labratyan, the Program Manager for the Center for Green Chemistry and Green Engineering of the Yale University. Please, Lars, the floor is yours.
Well, thank you very much, Katarina. And let me also first thank all of you for being here, despite all the difficult moments you have to go through. It's really an honor to connect from the United States. And I cannot really fathom that I'm seeing so many people connected in this event. This is just fantastic. And I also want to follow up on what Tetiana just said. So we're all here to start using green chemistry in the industries we are doing, in our work we're doing, in the universities we're working at. So I think it's really a great floor, a great opportunity to get so many interested and interesting people together, and under this umbrella, which is green chemistry. And maybe I can just start right away and share my screen, because today I'm here to introduce a little bit the Global GreenChem Innovation and Network Program, which is the program that brings us all together and even brings some colleagues from Serbia here. I saw that Branko Dunic is also on this call, and he will tell us a little bit about chemical leasing a bit later. So this is really a global effort, and we will have you participating. We'll have other countries, and I'm going to tell you a little bit about this project. But first, I would like to start off with setting the tone. So we are all here because we are using chemistry in one way or the other. And when we use chemistry, we are always using it with some good intentions, because we can generate a lot of fantastic products with chemistry. We can synthesize colors and pigments. We can synthesize useful materials, pharmaceutics and drugs and high-tech building blocks and things that we need for food production. So the good intentions of the chemistry we are doing day to day are actually the functions we want to fulfill with it. But then those functions very often come with harmful consequences too. And those harmful consequences might look very different, but they are harmful nevertheless. And oftentimes they pollute water, they will deplete resources. We are using chemicals everywhere to maximize our profits. We're accumulating plastics, as we can see in the oceans and in the rivers and in the forests. And then also chemistry comes with some inherent risk for accident in chemical plants. And finally, also chemistry participates in the forthcoming of the climate change, because it can we are generating materials that can cause climate change with chemistry. So we always have the inherent hazard in chemistry, that is the harmful consequence of what we're doing. So if we analyze that situation, it's quite clear that we always have to fulfill the function, but that we have to start getting rid of the hazards that we have used for so long, because we're in something that I would call a status quo, because so far our chemical industry and our work, how we approach chemistry, was always, oh, we will fulfill the function, and then we will see if we can deal with a hazard after. So we are setting the need for the function much higher than our own safety or than our own environmental health. And so this is where green chemistry actually came into play, or started. It arises from a necessity. It arises from the necessity to get rid and eliminate the hazards that come with green chemistry as a whole. And well, green chemistry, as you might know, and those of you who maybe are not familiar with green chemistry, it's somehow a framework that tries to redesign chemistry in the way that we design chemistry in chemical products and processes, thinking about the reduction and elimination of the use of hazardous substances. So we really want to get rid of them, and we want to redesign chemistry a little bit. And so the centerpiece of green chemistry are really the 12 principles of green chemistry, which you can see here on the bottom left. And they're somehow a guideline on how to approach the design of new chemical products. And here on the right side, you can see another little graphic. So when we are thinking about using and applying chemistry in one way, we're always thinking about the function, but green chemistry tries to bring the focus on designing for a function, but also thinking about the renewability of the feedstocks we are using, and making sure that everything is non-toxic to humans and to nature, and also making sure that the product finally is biodegradable. So we can always when we are working for a new chemical design, go through this graphic and analyze the steps. Is the function fulfilled? Yes. If the function is fulfilled, then make sure that the feedstocks are renewable, the material doesn't harm us, and that the material does not accumulate in nature. So this is the very basic of green chemistry. I know that we are going to hear a little bit more about the 12 principles in detail, just in a little bit. So I'm not going into more detail, but I want to show you a little bit about the Global Green Chem Innovation and Network Program, which is actually the program that's bringing us together. Let me just go ahead with so we heard about the 12 principles of green chemistry. Oh, I'm hearing some noise, but maybe that's okay. That's fine now. So we have the 12 principles of green chemistry, but of course we also have 17 sustainable development goals from the United Nations. And as you can see, some of them overlap in one way or the other. And that's why this program is so fantastic, because it's a program that is actually a connection of the United Nations in form of UNIDO, the United Nations International Development Organization, our center here at Yale, and the GEF as a donor, the Global Environment Facility, because we are really going to work on how to approach our common goal, which is a global sustainability. And what this program really is trying to do is establish green chemistry as an integral tool for a sustainable future. And we are going to do that by creating a global green chemistry network. So really bringing everybody interested or everybody already working in green chemistry together, and then use this network to amplify the green chemistry capacities worldwide, knowledge, also support innovation and inventions from industry and academia, and then finally also supporting local industries in the countries that are participating to reduce and substitute persistent organic pollutants, which is also a major goal of this program. Of course, our key partners are the national cleaner production centers, like our dear organizers today. But then we also have 5 other countries that are participating. We have your neighbors from Serbia, today represented by Branko. We also have Jordan, Uganda, Indonesia, and Peru participating. So this is really about bringing those partners together and working together to try to fulfill the goals of these programs. And I also want to show you a little bit who the organizations are that are participating. So I'm today connecting to you in green engineering at Yale. We are a research center, so we work on advancing science actively through research. We have a lab here, of course. But then we also work on catalyzing implementation through innovation. So a couple of companies have been created here at the university with technology that was developed here in the lab. But then, of course, we are also working on awareness raising through outreach activities. And finally, of course, we are a university. We do teaching, we prepare the next generation, and we try to bring green chemistry into the mindset of new students that are coming out of this university to step into the job market. Then, of course, our dear friends from UNIDO, they're another very important entity in this project. For those of you who are not familiar with UNIDO, UNIDO is the Industrial Development Organization branch of the United Nations. There are more than 170 member states and representations in more than 60 countries, and the headquarters are in Vienna. Okay. And what they are doing is they are trying to share prosperity worldwide with knowledge sharing, with projects, and with helping each other, basically. And they're also trying to advance economic competitiveness, strengthen knowledge and institutions, and doing all that while at the same time safeguarding the environment. And the Global Environment Facility, which is probably an organ that people are not too familiar with, it's actually a World Bank associated fund that was funded around 1992 in the context of the Rio Climate Summit. And it's an entity that gives out grants and also gives out co-financing and has projects in around 135 countries. And what the GEF is focusing about is, its one branch is on nature conservation in terms of biodiversity, forest sustainability and avoidance of land degradation. And then they also have a strong focus on climate change mitigation, safety and proper use of international waters, and chemicals and waste treatment, which is of course the area where this project is focused around. And the main goals of this very project are actually measurable goals. And one is the broad adoption of green chemistry in academia and industry. The other one is strengthening the position of women in chemistry, because we see that in many countries around the world, the position of women in chemistry is still not equal to men. There are still problems in equal payment. There are still, in certain countries, less women interested in science, and we really want to change that. And I think green chemistry is a fantastic tool for this too. And finally, of course, we also want to eliminate POPs, as I already told you earlier. POPs, here are 3 examples. For example, DDT, which is an insecticide that was used for a long time. But then also we are talking about flame retardants or water repellents that we want to substitute. And this project is divided into 3 components. And the first component, as I already mentioned earlier, is actually the development of a global platform for green chemistry, bringing the global community together. And the goal is to really connect engineers and chemists with entrepreneurs and investors and mentors and experts and educators and mentees to really learn from each other. And really have a communication platform where we can share resources, for teaching, but where we can also share case studies, where we can share new companies that are using green chemistry and really bring the knowledge around the world. Because we have to achieve the goal of global sustainability, and I think together we can do that better. And just to let you know, so we are currently setting this global platform up with some partners here in the US that are very interesting, because one is the ACS, the American Chemical Society Green Chemistry Institute, and the other one is Beyond Benign, which is an institution or an entity, actually it's an NGO, who is really focused on education, and green chemistry education especially. So this is component 1. And component 2 will actually be very interesting for inventors and entrepreneurs, because this program also seeks to set up local accelerator programs in the 6 countries that are participating, to really foster the innovation that is done in those countries and help the innovators to go forward. And for those of you who are not necessarily familiar with how accelerator programs work, so we try to identify technologies that are interesting and prepare and train the entrepreneurs, bring them together with mentors to bring forward the optimization and piloting of the technology, select the winner, and then really start the implementation, which is fantastic, because there are great ideas everywhere. And then finally, the component 3 of this project is actually the part of the project that tries to reduce POPs. And what we want to do is to help the participating countries to identify companies who are using POPs in one way or the other, and substitute those POPs with green chemistry alternatives. Because many POPs are, let's say, old chemicals, and there are new chemicals that are green, that are not bioaccumulating like those POPs are doing. And we can really substitute those POPs with green chemistry alternatives. And so the idea is really transform industries towards a more sustainable future, towards sustainability also as companies. And so here I can show you again. So we want to really implement those technologies, scale them up, and generate the measurable impact that Jeff, actually the donor, is asking from us. We know that solutions to our problems are everywhere. We just really have to work on them and implement them. And one important message that I also want to bring along is actually that laws, quality standards, and rules can also play a very important role for green chemistry. And we believe that if we can make a step towards implementing green chemistry in binding laws in each country, that can also have a huge impact, because green chemistry is not like a strict set of rules. It's more like a design principle. And if certain laws require sustainable design, that would be something very interesting for all the countries and for the world, quite frankly. And we also believe that quality standards, that the adoption of new quality standards, green quality standards, can really help companies to open new markets, probably to get into new markets. And we also think that the customs can play an important role, because finally, if we control import and export and make sure that chemicals that are imported and exported fulfill the green chemistry design principles, that has a huge impact too. And well, you might wonder how we can approach that, and we think that the first step is actually what we are doing here today, is to raise awareness about green chemistry, because only if people who are the consumers, but also companies, know what green chemistry is, will they also demand its implementation. Because humans are amazing, because they can ask for things, and if they know that green chemistry is out there and that products that were designed fulfilling the green chemistry principles are available, they will really change their consumer behavior, and that's something fantastic. So we want to raise awareness to become visible and to stay visible too. So it's really important that we set up like awareness raising ecosystem, and I think today is a fantastic example. I see that we have more than 150 participants in this call, which is amazing, quite frankly. And this is exactly what we have to do. We have to help people learn about green chemistry and ask for green chemistry solutions. And I don't know how I am time-wise, but this almost brings me to the end of my talk. So the timeline of this very project, so it was launched in the beginning of this year. We actually had a fantastic kickoff meeting where Olena from the team in Ukraine was also visiting Vienna, where we all came together, which was absolutely fantastic. And so this year we have been using to set up the network, to bring everybody together, to set the stage for a successful project, because then next year, probably in the end of next year, we'll slowly start the accelerator programs and then run three cycles of this accelerator program with the support of the network that we are generating in parallel. And then the idea finally is also that the companies that we identify to substitute POPs with will then, in the end of the project, have their previous POPs substituted by green chemistry solutions. So the idea is really to mobilize the green chemistry network and tackle not only the 12 principles of green chemistry, but also the global sustainability goals. And this leads me to the end of my section, my talk here. And I'm really looking forward to the next talk that are coming up, because I think it's really a great opportunity for us to come together and share our knowledge and expectations about green chemistry. And I can only say, if you're interested in what we are doing or in contacting us, please reach out to us. There are a couple of email addresses that you can see there on the left. There's also a link to our webpage. You can see a QR code on the bottom, on the top left. If you're interested in participating in this network in one way or the other, you can answer a couple of questions and sign up for it, and then you can receive a newsletter. And if you want to follow us on one of those social media platforms, you can also do that. We are active there as well. And let me please thank you, all of you, once again, to come together in such impressive numbers. And I'm happy to answer questions probably later, because we might go on with the next presentation. I don't know how we are time-wise, but please let me thank you once again. It's amazing to see you all today.
Thank you very much, Lars. Thank you very much for giving us the outline of the new opportunities available for the green chemistry as well. We have been definitely surprised that there is more than 100 people now participating in our meetings. I do hope that we're going to stay through the end of our meeting today as well. And right now, we will discuss how the principles of green chemistry are being used to improve the ecological safety of the production. We will listen to Alexander Hohotva, who is the Doctor of Technical Science, the Dean of Chemical Management Experts, and from the Resources of Efficient and Clean Air Production Center, and also is a professor of Igor Sikorsky Kyiv Polytechnic Institute. He is promoting the concept of the rational management of chemical components in Ukraine. He is the part. He has a lot of publications on chemical leasing and functional diagnostics. So I hope that I've mentioned all of this positions. And so, Alexander, please, the floor is yours. The one thing that I have seen the question already in the chat, dear colleagues, we're going to have a Q&A specifically dedicated in the end. So if it is okay for you, we're going to listen to all of the presentations and make sure that you will write down the questions in the chat. We will read them out during the Q&A. Alexander, please, the floor is yours. Good afternoon, dear colleagues, and I would like to outline the main elements about the chemical security issues. Well, basically, this is the term and the issues that is been frequently used in the media today. As it has already been said before, like the green chemistry is built on the 12 principles, it's been dedicated for the usage of the safe components, creating the safe components, broader using the sources, the renewable sources. We aiming to create the components and products that are going to be safe for the environment so they can be used additionally. And it's also about the work in order for us to avoid hazardous and dangerous situations and to improve safety. A separate point, they are specifically dedicated to environmental safety. The others maybe not specifically, but there will be some of the principles that I really would like to outline straight away and to give you the examples in what way the implementations of those green chemistry principles will help us to improve the environmental safety. One of the principles is about a safer synthesis of the chemical elements. So if it's possible, then the synthesizing methods have to be created in a way so that we were able to use and create components that will be as non-toxic as possible and as safe for the environment and other living organisms as possible. So basically, the most important thing that you should not use toxic components as your main source material. You should use, if it's possible, using the cascade reactions where less of the intermediary components are being created, the less residues are being created, and thus as the less stages you have, then the less waste from the productions and from the reaction you're going to have. As of now, the current chemistry, chemical science, and pharmaceutical chemistry, for example, has a tremendous experience of implementing or following this principle in the pharmaceutical industry because that's one of the most important principles for the competitiveness of the industries. For example, the polyurethane synthesis. For example, during the traditional synthesis, in order to produce the polyurethane, you're using the different cyanides, so that's going to be dangerous components that might cause the irritation of the skin, that can cause the respiratory diseases, and they also have the toxic vapors. With the help of the green synthesis technologies, you have to use the isocyanates. So basically, the products are going to have a better properties, a more sustainable properties, and the whole synthesis process is going to be safer. And using Another point that has been with the use of the toxic elements, it's about the whitening of paper. The paper is being used in very big amounts, and especially the office paper is whitened paper. Well, you can see basically the paper is more or less white, the one that we see. In the traditional whitening technologies, we're using the chlorus components, and we know that the dioxide chlorum, and we know that it's a very dangerous component, and we have the additional residues that the residuals that are toxic. Current technologies for whitening the papers were using basically the tetramido microcyclic ligand that is based on the ferrum components, and that ligand is a functional element, a functional analog. So together with the peroxide, the hydrogen peroxide, this ligand is very good in whitening the paper. The process does not require that higher temperature and it's more controlled and it is non-toxic. The next principle is about creating a more safer product. So the chemical components that are being created and chemical products that are going to be created and invented, they need to complete and meet their function, but being non-toxic or being as less toxic as possible. So we need to make sure that we will avoid the toxic dangers and the impact, for example, for the reproductive systems, the impact for the nervous system. And we need to also take into consideration the potential of the global warming for every component that is being used or synthesized. We need to understand the overall potential of this component and its opportunities, for example, for its accumulation in the main chains and how it's going to be accumulated in the living organisms. We need to also make sure that it's going to be corrosion safe and corrosion resistant. So all of these properties, there are some certain physical and chemical properties that impact on that. So any kind of chemical components, and you can also use the different variables of how they can be, the acidity of how you can combining the properties of the components, you can also impact the chemical properties of those components and products. The chemists, they can create the chemical components with a lower toxicity. Like, for example, when you're going to be managing the certain functional groups that you will use for the synthesizing of the new components, we understand that there are some groups that will help you to decrease the toxicity of the components. Also, it can also impact the bioaccessibility of the components. If, for example, this component is uh, not provided by the living organisms and it goes outside of the organism, then it's not going to have a toxical impact. We can impact all of that at the molecule of the chemical component that is going to be synthesized. The risks management. The risks is about, once again, the function of the danger and the time of the impact. If, for example, a hazardous product is higher, then we need to decrease the impact time up to zero. If the component is not hazardous, then the impact can be longer. And so basically, they will not impact the risk because the component is non-toxic. The final goal of the green chemistry is once again using the safe materials, the one that has already been identified with their impact. There is no clear reliance from the systems, for example, from the systems of preventing the hazardous events. And so the law says that will be, for example, created by the laws of chemical tools will be decreased as well. In the traditional risk decrease approach, the path of minimizing the impact is being used. And when they're working with a unsafe component by decreasing the time of you that you operate or using the individual protection measures, improving the ventilation, the general ventilation of the premise or the local ventilation with a specific laboratory where the work is conducted if the component is vaporous. The decreasing the risks also is possible by decreasing the danger or hazard. If there's no hazard, then of course we understand that there is a lower risk as well. The principle of showing this principle is about creating the foam for firefighters. Traditionally, we're mostly using the surface active components that are quite resilient. They can accumulate in the accumulate in the environment and they can stay in the same for quite a long period of time. A new form has been created and there was a stable to fight a corrosion and function-wise this mix is just as effective, but because it has all of the organic components and it can be biodegradable, and it is a very good example of the implementation of the green chemistry principle of using non-toxic components to create a safe product. Another example of implementing of this principles is about the pesticides. Everybody knows there's the DDT pesticide, that hasn't been used for a long period of time, but because it has been used for quite a long period of time in the agriculture before, it has accumulated in the environment because it is a very resilient component, both chemically and physically. So this component is quite toxic and it causes a lot of harm for the nature. To substitute this pesticide, the pesticide that is called the spinosyn has been created. It can be synthesized by bacteria. It is also impacting the nervous systems of insects, just as the insecticides either, and it shows the low toxicity and has a very good environmental profile. Another principle of the green chemistry that is promoting the increase of the safety is the principles of using a more safe components, and if not using, if we can use it, if we can avoid using additives, then it will be the best option for us. But then again, if we cannot avoid that, we should also use the safer ones. We use them during the synthesis and during the different chemical processes. So when we're talking about also the one that we're using with the higher acidities, they will be easily flammable uh, components, and because they can be also used with the water and then might be vaporous. There's something that is going to be definitely impacting the pollution for soils and waters. And if it is possible that we're trying to use the very same solvents during the regeneration, but these processes are quite energy dense. Speaking about the solvents that are mostly widely used, it's about those the chlor containing solvents, the chloroform, the chlormethane, the aromatic solvent, benzol, and others, alcohols and aldehydes. The solvents are being used for different reasons, and they're also being used, for example, in the fabrications of different paints and dyes. It's been used in different production processes. For example, also during the in the industries, the organic also solvents are using to disseminate different types of components in the complex products. It's used also to cleaning the surfaces, and quite frequently the solvents are also the main environment for the chemical reactions to be conducted. The solvents also may include some of the elements that can be explosive, that can be toxic and hazardous. They also have a very big potential for the climate change because the while of the vapors can be of the greenhouse gases. And in the framework of the green chemistry, there is a certain strategy of how we can substitute these dangerous and hazardous solvents. First of all, avoiding or minimizing the usage of solvents overall during in your technological processes. You can use less toxic solvents to use them, for example, the solvents from the renewable components that are not the products of the oil processing, and trying to avoid using more organic components. The alternative is also to use the chemical processes without the solvents, and it is going to be the mechanical process, and it is going to be some, for example, universal solvents that will be available to solve not only the organic components. And using additional, for example, components that can be used as a part of a solvent, for example, to use in the CO2 that can be used as liquid and then to come back into the gas state. The examples of how we can using the processes without solvents is about the mechanochemical reactions. When we are mixing the main reagents in the specific reactors, we can see that what is happening is the breakage of the components, and in at certain points, certain parts of where the connections between the reagents is being created, we have a higher temperature that's being created, which is enough to initiate the chains of chemical reactions. And as far as the reactions are being made in the disperse phase, the reaction is quite effective, the reaction is quite fast, and that there is no solvents, and thus we do not have the secondary pollution of the environment. Another example of using the alternative solvents is the decaffeination process for coffee. When it's with the usage of the CO2 in the classical technology for the decaffeine, when when using coffee, then we're using also the toxic solvent that can negatively impact the nervous system, that can cause headaches or that can cause nausea. So after the caffeine is extracted, the dichloromethane is going to be just evaporated. It is possible that the final product may have the residues of that. When we're speaking about the decaffeinated coffee, the green grains, coffee grains that are being first of all put into the water. So first of all, it's been the first part of the caffeine has been coated by the water. Then the grains are going to be processed by the liquid CO2. It's going to be extracting the caffeine, and then the caffeine from this liquid state, it's going to be once again washed out by the water, and the CO2 goes to the regeneration. So that is why then it's going to be used further on. For example, it can be used for the caffeine can be used for creation of the, for example, medical components and drugs that have been created by pharmaceutical companies and some of the sodas. So the chemical components have to be biodegradable. So they have to be developed in a way that in the end of their life cycles that would not be accumulated in the environment, but for them to be then dispersed to a non-hazardous products with the help of the different chemical, physical, and biological processes. In the previous century, we've used a lot of the washing components that were not really degradable in water that fully went through our main sewers and municipal sewers and filters straight away into the other rivers, and that is something that it caused foam, for example, in the rivers. And before we also use and the components that have been non-biodegradable, that also can be vaporous components that can get into the atmosphere and they can have the hazardous properties as well, and the DDT and other pesticides and insecticides that can be stored in the environment for decades, and that might also cause cancer. The examples of creating the elements that will be biodegradable are the pacificators, and the pacificators are the ones that are being used widely when we're creating the different types of plastics. That would be the additives that will give the flexibility and strength for the plastics. The lot of plastifiers that are being used, for example, when we're creating the polyvinyl chloride, there is about the phthalates and other components that can be also added to soft the plastics. But sometimes they can be hepatotoxic, so they can also be bad for the work of your liver and nervous system. So when it gets into the environment, together with the unrecycled plastics and waste, it's going to stay there for an unchanged state in the environment. What would be the alternative for this plastifier? There was created the diatom that is synthesized out of sturk, and we can substitute the toxic component in the very same amount, but it's actually is biodegradable, which gives the opportunity also to for the plastic material to be biodegradable, full almost biodegradable as well. Another thing about creating the plastics is about the polymers, because the traditional plastics, the PET plastics, they're being made out of the oil residuals, and those are about, they're very resilient toward toward the environment, and as an alternative, there was the polylactic synthesis that has been created. The main component is once again stuck. So that is why all of the components then are the components that can be then biodegradable and that can be used additionally. So all of the residues and all of the waste that is being created, that then might be used further on in the production processes. So that would be the alternative option for the synthesis of plastics. And this plastics that will be possible to use for the product, for the food products. A separate moment that I wanted to outline would be the POPs, so basically the persistent organic pollutants. So that would be the organic components and of different classes. They are resilient towards biodegradability and they're very resilient and persistent in the processes. They can be bioaccumulated. Some of them are also non solvable in water and water resistance. They can be once again seen. The residuals can be seen in water, in also in air, or can be the parts can be found as residuals in the birds and insects, for example. Some of them can be found, for example, in plastifiers, in the different types of additives. Some of them, they can be the biocides or the antiseptics. Also, the pumps, they're used in additional technologies, for example, in the liquids that are used for metal processing. The problems with those components that for a longer period of time throughout the decades they have been used in the production lines and thus they have caused they are widespread in the environment and we have a lot of the big amounts of those products that have been now accumulated in the environment. We understand that it's not good. We need to find the best substitutes to that and alternatives to those components. As of now, it has already been the tremendous experience and the green alternatives that have been created already for the different POPs that have been used in different sectors. As you can see, there's examples on the slides that different components of the different classes as well. The one that are a part of the POPs and the one that have been offered by the green chemistry to substitute with. Also, we need to have the overall control of the processes in the real time because for us to understand how to be able to control all of the processes, this is something that is going to help us to avoid to stop the processes and to avoid additional waste if something goes wrong. So this will help us to decrease the amount of waste and improve the safety of the processes. This principle has already been implemented in the cooling systems because the cooling systems, for example, at the power plants are using the biocides and decrease uh, in order to decrease the system, there is now a different system that has been created that helps you during the real time to track the amount of the mineral accumulating components and it will gives you to decrease the number of the biocides that are going to be included into the system when it's needed, but not because, for example, there is the high time to add some biocides. In order to prevent the in order to prevent the different disasters, we need to avoid also of using more biodegradable components, avoiding using of the molecular aggregates, and try to conduct your chemical processes in unbreakable regimes, so uninterrupted regimes. So basically, not in the periodical reactors, but as the flow processes. Of course, the task of increasing the safety and security of the processes and is important to introduce the principles of green chemistry throughout the whole life cycle of the product. And that's all from my side, and thank you very much for your attention. Yes, thank you very much, Alexander. Thank you very much for helping us to give a better understanding of how the green chemistry can help us to decrease the pressure over the environment and to improve the ecological safety of production. I would like to introduce you with our next speaker. Please welcome Branko Dunic. He is the director of the Cleaner Production Center of Serbia. He is an international expert. He is the PhD in chemistry in polymerous materials. His main part of activities is the optimizing of the processes, development of the synthesis of polymers, resource efficient and clean production, the green and sustainable chemistry, eco-industrial parks, and chemical leasing. So chemical leasing is going to be the main topics, and innovative business approach we'll be hearing from Branko today. So Branko, please, the floor is yours, and I would like to ask all of our speakers to follow the timing. So please, Branko, the floor is yours.
Okay, thank you very much, and I will try to be very, very short. It's a huge pleasure for me to be here, and it's also an honor to present something about chemical leasing, one new, relatively new business model that is also already proven to reduce consumption of chemicals, and I will also explain why we are talking about this in the context of the green chemistry. Also, I'd like to really repeat what Lars already said. I'm really impressed by your dedication and your commitment to work during the war, which is really unprecedented, and it's really a big honor for me to be in the same team as you are. So let me jump into chemical leasing and what is the chemical leasing. We all use chemicals, and that's why we are dealing with the green chemistry. And just before going into a chemical leasing, let me remind you, and all of you probably who are dealing with chemicals, you know already that the green chemistry is not the new chemistry. What is changing? Changing is just our knowledge about all the negative consequences of chemicals that we are using routinely. And now with all this accumulated knowledge, we can do something better, and we can really see how the chemicals that we are designing today and the processes we are designing today, how they will impact the future generation and our environment. And that's also the case with the chemical leasing. We are all using chemicals, but we are not interested in having a chemical. Why we are using a chemical is because we want that this chemical performs some function for us. And that's why in chemical leasing, the partners, the one who is selling the chemical and the user who is using the chemical, trying to sign a contract in which the chemical supplier here on the left-hand side is not selling the amount of chemical. He's selling, the producer and the supplier is selling the function of the chemical. And the chemical user, as I said, we as individuals or we are companies, we are not interested in having a chemical, owning the chemical. We are interested in this chemical to perform some function for us. So chemical user is paying for the service of chemicals, and I will go in a couple of next slides to show you the practical examples that are really in the real world, where the company is buying a function, not a quantity of chemical. This is the main message from chemical leasing, and all of this leads to more efficient use of chemicals. In the classical business model, which is unfortunately or realistically used in 95 or 99% of the transactions today, you as a buyer, you want to sell more chemical because you are paid for the quantity of chemical, and your user wants to use as little chemicals they can, and therefore your motivations are contradictory. You want to sell more, and this one wants to use less. So if we have this contract of chemical leasing, where you are not going to be interested in how much you are selling or how much you are using, but rather what you do with the chemical, then both motivations are less is more, because me as a supplier of a chemical, I'm not interested anymore in selling tons or hundreds or thousands of tons of chemicals. On the contrary, I am now interested to sell the optimum quantity of chemical that I can this chemical can do. And you will ask probably why it's not possible right now, because of different reasons, but also there is this lack of trust, and there is no really good motivation from both parties to sign such a contract. Of course, if we do this contract and we sign the contract based on the function, then you can see all the benefits of the chemical leasing, and there will be amount of chemicals for us, which is important, will decline, but the amount of money will increase for both countries. I deleted 2 slides in which I'm discussing all the details, but on the slides that you are going to receive, there are those 2 slides which clearly show that both participants, supplier and user, benefit from signing the contract of chemical leasing. There are some examples overview. We, when I say we, also including my friends and colleagues from Resource Efficient and Cleaner Production Center for Ukraine, we have examples from more than 300 companies, 300 cases in different sectors. So you can see in this table that there are sectors from agriculture to car manufacture and different chemicals which are included here. And you will see that we are speaking about non-core processes for those industry. For example, in beverage and food production, we are not speaking about chemicals which are in the recipe. We are speaking about some additional, auxiliary chemicals like adhesives, lubricants, and solvents, etc., etc. So you can see here what are the unit of payment, which is at the core of the chemical leasing business model. For example, here, if you are doing chemical leasing in hotel, the hotel management will not buy 100 kilos of detergent. They are going to pay per square meters of cleaned floor, and both parties will have really a clear picture how much chemicals they will use, and this amount of chemical will go down. And here I will use next 5 minutes to show you the real case study, cleaning of metal parts in one car part manufacturer in Serbia. And this case is not case anymore, it's business as usual. And this factory in which they are producing those car parts, bearings, they changed 3 or 4 times the management, but still they are buying chemical under this model, which proves that when the model is really successful, they will not change it in the future. So before the chemical leasing, when we worked with the factory, we discovered that the cleaning operation of these parts of in this factory was a bottleneck in the process. They were using toxic solvents, very high consumption. They had problems with machine parts, etc. Then we came there. It didn't come overnight. Then we studied the process. We brought the chemical supplier, somebody who is really very knowledgeable about the cleaning, and they agreed not to sell anymore the amount of chemicals, 30 tons per year, but they said, okay, we are going to teach you how you are going to use better and in more time the same chemical, and we are ready to sign a contract in which there will be no quantity mentioned, but rather a number of working hours by cleaning machines. So they agreed about this unit of payment. This change in the contract, so I'm not selling you a ton of perchloroethylene, but rather you are paying me per the number of working hours of your cleaning machine. triggered a whole series of optimization. The solvent was substituted but modified one. Then the solvent was recovered on site. And the waste at the end was taken back by the supplier. All of this was triggered by the fact that the supplier was now interested to really share his knowledge with the user. You can see the results of chemical leasing, which is really spectacular. When we started in 2011, I think, they were using more than 75 liters per ton of products of very toxic solvent. After application of chemical leasing and recovery on site, you see that there was a 7-fold reduction of solvent, fresh solvent consumption per same amount of cleaned material. Moreover, the waste was, you see, they were using 70-something liters per ton of product, clean product. The waste was almost everything. After that, the waste was really almost zero. Why? Because now, since they are now recovering the solvent in place, the waste is not waste, dirty solvent, it's oil which is removed from the parts. So you can see that they have, both of them, over 100,000 euros of savings, which is split between them, maybe 50-50, maybe 60-40. And then we have 7-fold decrease of solvent consumption. So we keep the same quality, the same productivity, and we reduce the consumption and waste of the very toxic solvent. Of course, chemical leasing cannot be used everywhere. As I said, we are mostly focusing on side processes which are not core proper processes of the supplier. For example, in car industry, we are not telling them how to make parts. We are just telling them how to use chemicals, and they are not specialists for cleaning. So we tell them, okay, you concentrate on this. We bring a specialist. They will learn you how to use it better. How chemical leasing can be performed. This is the simplest model that I presented, not really presented. So you have only supplier and chemical and user of chemical, but the model B, which I presented right now, is the supplier of chemicals and equipment supplier. They join together and they offer the complete solution to the user of chemical. And the model C, which is even better, is that you have supplier of chemical, equipment supplier, other partners, for example, recycling company, and they offer a complete solution to the user, which has controlled costs. And finally, this is my final slide, is that for a model to be sustainable, there should be several criteria which are fulfilled, and you can find those criteria there. Since I'm not going to discuss each of them, but as I said, this chemical leasing started in 2012 in a car parts manufacturer in Serbia. We are now in 2023, so 12 years they are using the same model, and it proves when all the criteria are met, sustainability and economic criteria, then the model is really performed. At the end, I'd like really to thank you very, very much. And it's always a pleasure to be with my Ukrainian friends. Thank you very much.
Дякуємо.
Thank you very much. Thank you very much, Branka, for all of your kind words of support. It is very important for Ukraine. And thank you very much for showing the new opportunities for our businesses, for being more environmental Thank you very much, dear participants, for being very active. And we do have some questions, and our experts have already been providing the answers to that. So please make sure that you will ask your questions if you have any. And right now, I would like you to invite you to listen to the information about the integration of green chemistry course into curriculum. Dr. Ludmila Vratic, the professor of macromolecular chemistry department, Faculty of Chemistry, Taras Shevchenko National University of Kyiv. So please, Ludmila, the floor is yours. Yes, thank you very much. You can now see my presentation on the screen, and I hope that you can see that well. Yes, we can see that well, and it would be very good if you can make it full screen as well. So, okay, I think it works. And I would like to do a very quick outline of our experience as the representative of chemistry department in Taras Shevchenko National University of introduction to the new course on green chemistry into curriculum. The first issue is, of course, why we have made this decision, what made us make this decision. So the thoughts about introducing this course have appeared for us like 3 years ago because we have certain trends as well and tendencies. First of all, we have understood that in international universities that are same as ours, then we have seen the master's programs and the programs for the PhD programs with the green chemistry programs. We have also seen that we have seen the new terminology, like the green technologies, the green product that has been used. And we have also seen and experienced that in our country, even though we have seen the products as well with the usage of this green terminology, but what we have seen that we didn't have the enough awareness in the society about what the green chemistry is. And of course, as for every university, we are fighting for the same. That's one of the reasons. That's one of the reasons that it always keeps us moving on. Is about fighting for our future students. We always need to feel ourselves competitive. So, in my point of view, what it is needed for our course, for example, for the course as green chemistry is to be implemented. We need the professionals. We are a chemistry faculty. We have 5 different departments, and we have different departments: the organic, non-organic, the chemistry of the higher molecular components, and some of our some of our departments had the experience of working with the same professions like ecological chemistry. For example, in the inorganic chemistry, we had for more than 12 years of experience. And also in the department that I represent, in 6 years, we have provided the special course for the chemistry of polymers for our students. So the professionals that we do have professionals in our faculty, that's definitely very good for all of us. And even the opportunity, having these technical opportunities to combine the educational components is very good for us as well. So a very simple tasks that we are doing is we need the initiative of our teachers to present certain ideas for the your department that I really would like to start working with a certain course, and if the department will agree to that, that we're going to be using that at the methodological commission on the faculty, and then we will then approve this course by our scientific council. Speaking about the time frames, then for the next years, it is already available with the new courses are already available for the next year to them. So, but speaking about what it is that we have today, what it is that we have as of now, our department starting from 2016, has been teaching and has been providing the teaching of the voluntary course on green chemistry. That is for the second year of studies at the bachelor program, at the bachelor course. We have plans. We have plans, and the other department has already been implementing those plans. The department that I've already mentioned that has a tremendous experience in the another profession that work, the non-organic chemistry department. It is planned by the non-organic chemistry department for the next year, for year 2024-2025, to launch a new specialization, the green chemistry, for the master's level. From what I have seen, that we already have the head of the department of the non-organic chemistry. So I think that if you will have some questions, then you can get the answers from him straight away. And about us, I think that I also would like to add that speaking about this discipline, the voluntary discipline for the students. So what do we have? For example, we have developed the program, the curricula, and you can see the link on the slide, based on the knowledge that we've had and based on the literature that we have processed as well. For example, in 2018, there was an Ukrainian language textbook of 90 pages, the green chemistry. What are we telling to our second year students? That's the philosophy of the green chemistry. And the philosophy is as follows. We need to show the students overall what the green chemistry is about. That it is about chemistry, but with a new approach, with a new philosophy, with the philosophy of being careful about the results of the chemist's activities. So I have made this book in a way, so we are outlining the need for the new approaches to design the chemical products and processes. We're also discussing here all of those different international documents that, for example, Ukraine has signed, and like the Kyoto Protocol, the Stockholm Convention, and others. Of course, there is a part when we are discussing the main approaches of the green chemistry with our students, and we're discussing the 12 principles, and we are telling them that there's new approaches on the quantity approach and evaluation of the chemical reactions. And we also give them the practical examples of implementations of the green chemistry principles. And we are having a very detailed discussion about the polymer material, biodegradable polymer materials, and we can do that really professionally. Speaking of that being a course of a free choice, I'm usually giving this statistics, and based on this statistics, how many students have chosen this course as their course of their voluntary studies. Knowing that we have a slight amount of our students changed at the year two, then we usually have around 80 students or 80, 100 students. So unfortunately, this year we only have 60 students this year. So counting in the absolute number, I think that around 50% or even more, they're choosing green chemistry as their discipline of free choice, as voluntary choice discipline, and they are studying it really passionately. And now about this new specialization, I will try to be very brief on that because it's about a different faculty that works there, but they have a very powerful collective there working on that. There are a couple of our teachers and professionals who have had experience of teaching the environmental friendly chemistry. They have lots of results in their work in the environmental chemistry already right now in 2020. They've had a book that has been also published on green chemistry. It has both the traditional parts and it also has the new parts of there on the basis of the green energy, the opportunity of using the natural minerals and the green technologies, the green accumulators. These final chapters are mostly connected to the main scientific work of the educators that are going to be teaching this course. I will give I will also, if we will have some time, what can be the topics, for example, for the thesis works that I'm going to be completed right now at our department, in the framework of our department. I also would like to draw your attention when I have this chance about what kind of sources, informational sources we have, and what is might be felt as problematic for us. For example, the recommended literature that I have chosen for 2018 for our recommended books is in English. So right now in our curriculum we might use some additional books that have been already published with the help of our course as well. So for example, I'm also offering my Ukrainian language book, but the the basics, the classical, and the best and the most professional literature right now is in English right now. And thus, it is a certain problem for us. There is a certain problem that we do have this lack for our students for the printed uh, options of the books. And let us say those are the classical books on green chemistry, or there is a limited access to our licensed access to the corresponding books for if we're talking about the access to the e-books, we do not have that in the full scope. And for me, as for the lecturer who cares for this discipline, I see that as the biggest problem and as the biggest challenge for us that we do not have the access to a high quality main basics literature in green chemistry that will be good to use in our training, our educations, and in our references. We cannot, of course, force our students to only read the English language resources. We need to provide them the opportunity to read those topics in Ukrainian as well. And I believe that that is one of the biggest problems that we have as of now. I do understand that right now we don't have enough resources for that, that's for sure. Unfortunately, we're in a war now, but I do hope that at some point our voice will be heard and that we will have the work that will be established to create this kind of publishing houses, the one we're going to have, the good literature, training literature translated into Ukrainian from all of the main directions in green chemistry. And I also wanted to mention that we have the professionals who teach in certain disciplines. They are also conducting their work in this direction. We do have the people in the non-organic department that are working on this topic. Our students are joining us and they're conducting their thesis works in this direction. And we also have this joint work between the departments of non-organic chemistry and the high molecular components chemistry department in creating the solvents for and the sorbents for creating for cleaning the of the water. And also, I wanted to say that we're really interested in the different types of collaboration with those educational institutions that also have the green chemistry disciplines and specialization in their curricula to be able to also offer this students exchange, experience exchange, and even the textbooks exchange if that is possible as well. So thank you very much for your attention. I've tried to provide my presentation as fast as possible. Thank you very much. Thank you very much, Ludmila. Thank you very much for sharing this experience of successful introduction to green chemistry course. Thank you very much for sharing all of the challenges that you've met, and thank you very much for emphasizing the knowledge in this sector for the future chemists. And now, having discussed the theoretical part of that, we would like to offer our participants to switch from theory to practice. Together with Dr. Dmytro Bidyuk, with the co-founder of the Ukrainian sustainable brands Food Biopack and Recover brand, he is PhD in technical science, engineer and engineering product sector. The basis of the products for that Dmytro has invented and created is about sustainable development. So Dmytro, please, the floor is yours. Good afternoon. Good afternoon. It's a pleasure for me to welcome all of the participants. It's a pleasure for me to be a part of this conference and to have this opportunity to tell you more about the results of my work, the results of work of my colleagues that are the part of also using the principles of green chemistry that has already been voiced out. You know, having listened to all of those presentations today, that was really interesting for me to learn to listen to the different directions for the possible work and to know more, to get more about, like, for example, that we're going to have a specialization in green chemistry as well, because even though I am an engineer in food production, I have this desire, you know, even at some point of time, I've even started to think about it, you know, they're having the second higher education in chemistry. So right now I'm going to even think maybe I can join Taras Shevchenko Kyiv National University in this specialization. But right now I'm going to turn my presentation on and just to start with a couple of words about our journey. As I have already said, I am the food products engineer and in 2015 I worked on my PhD thesis in the food production technologies, and as a part of that, I've made a certain invention that has changed my life, and I have switched from lecturer, from teacher, and I had more than 13 years of that. I've turned into entrepreneur, and mostly entrepreneur that introduces the components into the real life and develops the technologies in the circular economy principles, the principles of sustainable development, and to make sure that these products can be commercially successful. So I will launch my presentation now. Yes, so my presentation is called the Startups from Idea to Implementation, and you can see in the slide as though the two startups that I have co-founded. I have co-founded with different partners. So the Food Biopack and the Recover project. The Food Biopack project was founded in 2018, and as I've already said, when I was working with my PA on my PhD thesis. And the main invention that was a part of the Food Biopack product, it was just made by chance. And by chance, when I was working with high molecular, for example, like the proteins and the polysugars, I have received a certain film. You can see that I've received this film, and based on this idea that I can use the edible components to create the biodegradable packaging, biodegradable posters, we created the first prototype of a cup. And you can see that on the left photo. Of course, it then became something that inspired me to continue in working in this direction and to change my qualification a little bit. Being the engineer in the bioplastics, in the high molecular components, and becoming a person that would like to introduce that technologies into everyday life. So among the products of the food biopack that have been developed at that time, and the product has started from 2018, as I've already mentioned, and up to year 2020, we have paused the project due to certain reasons. But throughout these 2 years of experience, by using the educational approach, by using the specific equipment, we have created a certain range of products. The film, for example, that has become the part of our packages, the packages for food products, non-food products, and other accessories. The main difference from the polylactides that my colleague has mentioned is that we haven't synthesized those components, but we have used them in their natural ways, and only in the process of the technology processing of those products, we have created this film form that has certain properties. So it's plastic free. It means that it is created as an ecological alternative to plastics that is going to be degradable really easily. For example, it can be then biodegraded in the soil up to 1 month. So, for example, compared to the polylactides that require specific conditions for composting and degrading, so they need high temperature, they need certain moisture regime. So, in our case, our film and our products, they can be degraded in the home conditions, in natural conditions, up to 1 month of time. The main component is the recoverable components and secondary products. So basically, once again, using the principles of the circular economy, and we're trying to make sure that we're going to be using the secondary components. So we're trying to use the secondary components, the nutritive components that, for example, are left over from the restaurant businesses that might not be used further on or might be thrown away later on. So we can also give it as example, for example, the leftovers of coffee, the leftovers of corn, the leftovers of the eggshells, and others. Speaking about the biodegradability, because, like, for example, it can be degraded into the natural conditions and in the industrial compostment. So you can see the results of our research that we have conducted in the um, what we have conducted in the soils and in the laboratories, and you can see that our film, as an example, has degraded in the laboratory conditions. And what we mean by the lab conditions, so when we're creating the ideal conditions for the biodegradation, a certain moisture level for the conditions, the availability of the certain microfloral availability, the temperature has been provided, and by these guided conditions that have been constantly held for 40 days, our film has been fully degraded, as you can see on the photos. Speaking about the conditions for the soils, then this packaging, that would be an already made product that has been the packaging line already. We have then taken it into the soil, and we have researched the dynamics of the dynamics of the biodegradation that you can see on this slide. And of course, because the natural conditions there are not managed, and for example, there might be the risks of the high temperature, or there might be the impact of the high moisture level of precipitation if it's going to be raining, for example, then under those conditions that we have conducted that before, then we understand that it would be biodegradable a little bit faster than under the laboratory conditions, and that was due to the high level of moisture that was by that time, and because it was during the summer. Speaking about the Recover project, the project that has been created in 2019, together with my partner Yuri Tesanovsky, we have combined the both of us. I am the PhD in technical science. He is the PhD in economy. So we're the professional of our sectors. I know how the food production, and he knows how to be the entrepreneur. He is entrepreneur by profession. So the main idea for the Recover was to use the waste from coffee, for example, that can be seen in the restaurants or in the coffee shops, in the gas stations or the others premises that use coffee, and the enterprises, for example, the one that are using the coffee, for example, the Halka plant in, for example, in Lviv, that has creating the instant coffee, and they have a lot of coffee leftovers. So we would like to use this very good component that has a lot of important and valuable components in order to create a certain material that you can use to, for example, uh, exchange the different hard packaging. So you can see right now the products that we have created in these 3 years. You can see that part of the products have already been implemented into production. We have sold them successfully throughout the year. For example, in this top level, you can see that would be the candles. The candles, for example, when they use the cups from coffee, then there's also the cups that you can use that are also made of coffee. You can see, for example, the planting pots that can be used, for example, like this as well. So the capsules for the coffee machines and the coasters, for example, for drinks or any other things. Speaking about the benefits of these products, the main benefits of these products are that they are better biodegradable, of course. They are a little bit thicker. They can be biodegradable as well up to 4 months. They do not have any plastics in it, so there's only about the food components there. There was no additional biomodifications. They have only been processed in a certain way. So the component itself, it's not just the coffee that is a part of it, but that all has been already processed and recycled. And all of the components are renewables. They can also once again be biodegraded, both in the home conditions and in the industrial biodegradation and composting. And we're trying to use the approaches of the eco design as well, so that we will introduce the green chemistry principles in our products, for our products as well. So speaking about the one time, speaking about the additional, we haven't launched yet the apps that can be used, and there has been a lot of facts that unfortunately impact that, and due to the full-scale invasion of Russian Federation, and there's something that is slowing this process down, because we need a lot of investment to do that and a lot of equipment to do that. So that is something that we're working on, and we would like to launch this line in the long term. So we also have this recover cups, and that would be the once again, disposable, compostable cups that we would like to use, and you can see them on the photo as well. We have developed those on our own. We have a scientific lab. We have an amount of people who are dealing with this and who are working on this project. And speaking about the technology itself, on this slide, you can see, and it is shown on the slide, that's after since one espresso, you can see the 14 grams of coffee grounds. And out of those 14 grams, this 40 grams is enough to create one recover cup. So the technology is that we are collecting these coffee grounds from different sources and from those that generate those coffee grounds. We are then cleaning that, processing it. We are conducting once again the deep processing. Our technology is really resource sustainable without no waste, because all of the components that's being used during the waste, we are using that as well. For example, we're using as well the coffee oil that we're going to be using additional products like candles. For example, it might be used as the aroma component, as the fueling component. Then we're using the coffee extracts that can be created during the cleaning procedures. We can use it in the additional packing. We're using as an additional colorant and other ideas and ways of disposing it. Since the in-depth processing of the coffee grounds, we're creating a mix with adding other components that is then being pressed, and the so-called compression forming under the specific pressure. As a result of that, we will receive the products that you see. What else has to be outlined? That for the dishes, we're using the natural barrier coverage inside. That's again the coating that is reminding us of the BioCup project as well. This film prevents the direct contact with moisture. And like, for example, these cups have been developed specifically for cold and hot drinks to stop the diffusion between the coffee grounds and other components. And in order to use that, we've used this food coating. These cups can be used as well, and then these cups are going to be composted in 3-4 months. They're going to be fully degraded and they can be used as fertilizers for the plants that might be used further on, for example, for growing all of it. So basically, there's also a cycle that starts from the very beginning. Those are the candles that you can see on this. This is the final product that is already being sold. And you can see that we're using the coffee grounds cups, and there you can see that inside of the cup, and I haven't mentioned that as well, but that is something that we have developed as well. That is also the coaster from the eggshell. So we've created the so-called egg bioceramics that helps to prevent the fire hazard, so it's heat resistant and biodegradable. And we've used all of those properties just to then substitute the metal holder in the candle that and to make a fully biodegradable container. At the second photo, you can see how the candles look like in the packaging. Our candles have been developed and designed they're inside fully natural, so that is a high quality soy wax, and it's the natural wick from wood or cotton. There's a certified dyes and certified aroma oils that for the candles. And we have created a series of candles with the aromas that are dedicated to the cities of Ukraine. You can see Sumy, Luhansk, Carpathian Mountains, Kherson. So it's quite clear that, like, for example, that Kherson smells of watermelon as our candle as well. Crimea smells of grapes, and Sumy smells of linden, for example, and so on and so forth. So speaking about the uh, biodegradable plates, and you can see that it's all we had our own research, and you can see that they have been fully biodegradable and defragmented, and they've been then posed into flakes. Our team is made of the co-founders, that's myself, and Mayuri, my colleagues, that's us. On the left, you can see the link to our website and to our internet shop where we're selling our candles. And if I may, just to add a couple of words about the investment as well, that in framework of our project in Rekava, we have engaged around 1 million hryvnias for different grants. That was both the grants from the state and the grants from the donors and from the outside, from the US, from Norway, from Denmark. There has been many different private foundations that have worked in Ukraine and from different private structures. It's something that has given us the understanding and reassured us that we're going into the right directions with the development of this project. But one thing that I also wanted to add that when you are an entrepreneur working with science, it's a very important and useful direction because we're using all of our knowledge for improving and creating the product that would be beneficial and it would be important for both the society and the nature. Thank you very much for your attention. Yes, thank you very much, Dmytro, for sharing your experience in creating your products, and thank you very much for sharing the challenges that you have faced. We wish you the best of success, and we hope that you will complete your PhD thesis. And Dmytro, I would like to ask you to stay with us because we switch into the next part of our questions. So I would like to start with the questions that we have in the chat specifically for you. So we have two questions from Lyudmila Vretik, from our previous speaker, and There's two questions. The first question is questions about the resilience of and the sustainability of your materials, for how long your products can be used before the biodegradation. Now, our products are disposable products, and they can be used throughout a long periods of time. But because the products that we have created, they're disposable products, and they need to postpone non-ecological alternatives towards the plastics, and for example, the disposable plastic cups, then we believe that that would be a year. That would be the due date for this. Like, for example, you can store it in your storages for a year, and under the conditions of right storing, for example, the moisture level and temperature, for example, like any other food products, it can be stored in the storage for a year. But after they have been used, so after they have been used as plates, and after the right utilization, if it's going to be sorted into the organic fraction, and after the compostment, it's going to be really degraded in the fast way. And you have seen this time frame of its biodegradation in my presentation. Okay, thank you, Dmytro. And whether the products, whether they have some specific smell when they're being stored. That's an interesting question and a practical question, because the first prototype, yes, they've gained certain smell, because if we're talking about, for example, the coffee grounds, then in our process of research, we've tried to clean it as much as possible so that the powder that would be created would not have the specific coffee smell. The first prototypes they did had the smell. They did had a smell, for example, of oils that the coffee grounds also has. But when we have improved the technology and we were able to fully take down the coffee oil, that one might be the main source of this unpleasant smell, and at this stage, our products then they also covered with a specific coating that doesn't have any specific smell. So these cups can be also stored without any additional smell coming and without any additional smells or tastes that are going to be then used when you're going to be storing the products. Yes, thank you very much. And the final question for you as well from Yegor Skorohodko. So do you believe that the commercial opportunity it's not the best choice for the development of the economy of Ukraine, the exports sector of Ukraine, and the economy of Ukraine overall? Can you comment upon that? I just want to clarify, is the best or is not the best? I didn't get the question in the right way. Is not the best. Is not the best? Well, I would like to say that, like, what is the point of science, actually? Let me start with that. In my point of view, and this is something that will be my subjective meaning, it's just, the research and the research in the university, because, I'm a university professor as well, and I know how we're teaching people in the university. So the science is about creating the products according to the market demands and getting it into the market as well. So basically, to do something that our customer needs. And that is about the law of marketing. And basically, that means that, like, in my point of view, it means that you have to conduct the research, understanding the practical implications of it. And in my point of view, that's the best option for the further on introduction into production. Thank you very much. Thank you very much, Dmytro, and thank you very much for your presentation. There's been a lot of gratitude in the chat for your presentation. And we still have some questions for Lars Rutian, but I think that the question needs to be clarified, and we will then wait for the clarification. So I think, Lars, can you please answer this question either in the chat or you can try to comment upon this right now? What would be your choice? Would you like to comment upon it?
I can, if the interpreters are still here, I can also comment on it quickly. So
Так, перекладач з нами, прошу.
Okay, I think Igor is asking how we organize research here at the university. So typically when we have a research project coming up or a project like this, we generate a team around it. And usually research projects here are always somehow carried by the PhD students, and then the PhD students, depending on their experience, they might get associated to a postdoc, which has usually a little bit more experience and can help guide the PhD student a little bit. And then if there's a lot of work to do in the lab, then the PhD student might also ask for additional help in like undergrad students that can help with the lab experiments if it's a laboratory project. And that's the typical structure. And then we will have usually regular meetings that might be weekly or bi-weekly to see the research progress, to solve problems, to help the students solving their problems. That's usually a structure we apply for university research. And then for a project like this one, like the Global GreenChem Innovation and Network Program, it's slightly different. It's not a research project. It's more like a project management based project. So we have a team of professionals that are working on it. So myself, I'm a scientist by training, but I gained some experience in project management, and we have other people that also do project management who coordinate the activities around this project. So it always depends a little bit on what the focus of the project is, but typically research projects are structured with a student that is leading the project, and then depending on the intensity of the project, there might be postdocs and also undergrad students associated to it. I don't know if that really answers the question. I hope it does. If not, you can also continue discussing if you like.
And thank you, Lars. I'm sure that the answer has been provided fully, but still, if there's going to be some additional questions, let us know in the chat, and we will pass the questions to our speakers. And as I've already said, we're going to be this platform for the exchange of our experience in the development of green chemistry, and we're going to be searching for the answers to all of your questions. And so I am actually very pleased, and we have a lot of positive opinions towards our presentations and to our presenters today. We're really grateful for all of the kind words of your support. And just to end it up, I would like to thank all of our participants for being active, and I hope that you have had this time and spent it productively, and this event has given us the opportunity to make the very small step in introducing the green chemistry in Ukraine. And I would like to remind you that we're going to be working for 6 more years, and there's a lot of activities in this direction. Please follow the news at our official pages and the social media so that you would be aware of all of the interesting projects. Thank you very much for your participation. Hope to see you in our new activities and in the new activities dedicated to raising the awareness of the green chemistry in Ukraine. Thank you for being with us. Goodbye.